In section 1.8 we deal with coordinate geometry. Now coordinate geometry, I'm sure you've all seen before. It's when we have this grid, sometimes known as a Cartesian grid after the French philosopher Descartes, where you have the x-axis going along here horizontally and the y-axis vertically up here. And then it's possible then to graph points, for example this point here on the grid. This point is the point 3, 2, because if you start here at the center, 0, 0, the origin, you go 3 to the right and 2 up. The 3 that you go along the x-axis is known as the x-coordinate, and the 2 is the y-coordinate. So x is 3, y is 2. Similarly, there's another point over here where you'd have to go, start at the origin, go 3 to the left, so -3 and 1 up. Now, it's also possible to graph regions in the coordinate plane. So effectively all the points that obey a condition. So for example, if the condition is that the x-coordinate has to be less than 0, well, think about where x would be less than 0, where the x-coordinate would be less than 0. If I look at this grid once more, where is the x-coordinate less than 0? Well, it happens here, when the x is -3, here the x is -2, but if you look over here, the x is positive here, so this whole area here, what we call quadrant 2 and quadrant 3, all of that has x-coordinates that would be less than 0. So if we wanted to graph this this area here, the region x is less than 0, what we've got to do is graph the coordinate grid and just shade everything that's to the left of the y-axis, like so. Now, if your condition is that x is equal to 2, that's saying that the x-coordinate has to be equal to 2. Now let's just have a think about where that would happen. The x-coordinate on this grid is equal to 2 right here, but it would also be equal to 2 here, and here, and here, and here, and here. Anywhere along this line, the x-coordinate is going to be equal to 0. This is the point 2, 3, 2, 2, 2, 1, 2, 0, 2, -1. The x-coordinate is always 2. So, to graph x equals 2, what you need to do would be just to draw a line, a vertical line like this. And then finally, if you wanted to graph y, sorry, this I should mention is the absolute value of y is less than or equal to 2. That means that y could be 1, because 1 is less than or equal to 2. Y could be equal to 1.5. Y could be equal to 1.9, but it could also be y could also be -1.9, because the absolute value of -1.9 would still be less than or equal to 2. So, if you wanted to graph that, this would be the area. You'll notice that the y-coordinate here would be 1, y-coordinate here would be 1.5, the y-coordinate here would be 2, the y-coordinate here would be -1, but the absolute value of -1 would be 1, which is less than or equal to 2. So it's between these two lines. Now, on the second page, we're shown a couple of techniques. Often we need to find the distance between 2 points on a graph. So for example, if you needed to find the distance between this point here, the point 2, 1 and the point 6, 4, you can use the Pythagorean theorem. You can find out what the length of this bottom part of the triangle is, the length of this part here, and then just do 4 squared plus 3 squared, and then take the square root of it to get 5. And that's what this whole thing here is. The 6 minus 2 is purely to get the distance between this point and this point here. Because this point here is 6 along the axis, and this point here is 2 along the axis. So this distance here is just 6 minus 2, gives us 4. And this distance here we get by doing 4 minus 1. Because this is up at 4 and this is down at 1. Okay, so it's square root of 4 squared plus 3 squared. It turns out to be 5. So this distance here, AB, is 5. More generally, we have this formula down here, where if you have points A and point B, you just subtract the x-coordinates and square it, subtract the y-coordinates and square it, add them to two things together and take the square root. This is just Pythagoras applied to this triangle here. Now applying that in an example, we can just take these 2 points and imagine that this point here is A, so the x-coordinate of A is going to be 2. Right? So we're going to replace xa with 2. We're going to replace xb, this one here, xb, with 6. The yb is going to be replaced with 1, and the ya is going to be replaced with -2. And really from there it's just about plugging in the values that we have. We do 6 minus 2 squared, and then 1 plus 2 squared. Again, in this example, we happen to get 5 as our answer. And then there's another technique that we have if you want to find the midpoint of a line segment. So if you have a line that goes from A to B, and you want to know the coordinates of the point halfway between, it's very simple to do. Just take the average of the x-coordinates. So you add the x-coordinates together and divide by 2, or take half of it. You add the y-coordinates together and take half of it, and that gives you the coordinates of this point here. So, applying that to an example, on the next page, if you've got 2 points, 3, 2 and 7, 11, just take the average of 3 and 7. So you do 3 plus 7 divided by 2. That's 10 divided by 2, which is 5. And 5 should be the coordinates of the x-coordinate of the midpoint. And you can see that here, that 5 is the x-coordinate of the midpoint. And then, of course, you take the average, you take -2 plus 11, -2 plus 11, and take half of that to get the y-coordinate of the midpoint. And that's it.